Okay, so how do we use Ohm's law? So if I have a 120 volt battery with 20 ohms of resistance, what is my current going to be? Well, I'm solving for current, so I'm going to use I equals V divided by R. I is going to be equal to my 120 volts divided by my 20 ohms of resistance, and I get a current of 6 amps. What if I have 30 ohms of resistance and 30 amps? Well, I'm going to use my V equals IR equation. And I'm going to get 30 times 30 ohms times 30 amps, and my voltage is 900. And then lastly, if I have 40 amperes of current and a 160 volt battery, what is my resistance going to be? Well, resistance equals my voltage divided by my current. 160 divided by 40 gives me 4 ohms. So you're going to be working on this assignment where you have to come up with your own analogy, much like the river example, and then answer relationship problems about voltage, resistance, and current. So magnetism, how does this all relate to magnetism? Well, magnetism is honestly really complicated and it's deep and a mysterious concept, but it has a lot of similarities and relationships to electricity that we're going to talk about. First, let's talk about a few differences. First one is that magnets are dipole, meaning they both create fields, right? There's an electric field and there's a magnetic field, but all magnets have a north and a south pole. So the magnetic field lines are going to wrap around, going from north to south. And even if you break this magnet in half, it's just going to form two new magnets with a north and south pole. And you can keep on doing that, and you're still going to have these these magnets. So you're not going to be able to get just a north pole or just a south pole. Some similarities. So we notice that they do both create fields. That's how magnets interact with each other. One really interesting part is that the magnetic fields are defined by the effect that they have on a moving charge. So we know about magnetism because we know about electricity. The movement of electrons causes magnetic fields. Again, currents in a circuit create actually magnetic field as well. So your phone, computer, TV all create a magnetic field. Very weak, but it is there. And motion, it should be noted that motion inside the Earth's outer core and the iron nickel alloy there is what creates the magnetic field of the Earth. Okay, so how to create a magnetic field? One way is to have a current of electrons through a wire. That's going to create a magnetic field. The other part is sometimes they just occur naturally. These are permanent magnets out in nature. So ferromagnets is the name of the magnetic materials that just exist in the natural world. Paramagnets are temporary magnets that, in the presence of another magnetic field, become magnetic. So refrigerators, if you stick a magnet to a refrigerator, technically your refrigerator at that point is a magnet as well. But if you take away the magnet from the refrigerator, your refrigerator is no longer a magnet. So the first way to figure out where a magnetic field is going is to use our first right hand rule. So you're going to need your right hand for this. And it's really simple. If I had a wire, let's say this pencil is my wire, and I grabbed onto it, the direction of my thumb is the direction of the current. So if the electrons are going up, I'm going to make sure I have a thumbs up. If they're going down, I'm going to have thumbs down. And the way my fingers wrap around the wire, that's the direction of my magnetic field. And my magnetic field is going to be represented by a capital B. So here I can see it's wrapping around counterclockwise. Okay, we're going to come back to this.